Hello, welcome. I'm Valentin Deleplace. I'm a developer advocate for Google Cloud Platform. Today, we'll be talking about AutoML, which is a generic term for automated supervised machine learning. Supervised here means train a model by giving it sample inputs and the correct answers for these inputs. And more precisely, we'll talk about AutoML for image classification. First, a bit of storytelling. When I was a kid back in the 90s, I saw this awesome movie at the cinema. It was a stop-motion animated movie in which one of the characters was a penguin. And in the plot of the movie, the police was actively looking for a dangerous criminal chicken. And at the end of the movie, the chicken removes its comb, which was in fact a red rubber glove, and it's revealed that he and the penguin had been the same character all along. So my point is, if a rubber glove is enough to protect the anonymity of a penguin, then a black rectangle on the eyes should be enough to hide the identity of my two heroes today. Here they are. So do they look familiar to you? No? OK. Completely arbitrarily, I'll refer to them as Wallace and Gromit to protect their true identity, of course. Now, I'll start a demo. Why a demo right now? Because a model takes a few minutes to train. So let's switch to Google Cloud Platform. So I'll be using AutoML Vision, which is part of Google Cloud Platform. I already have an account. I get to Vision. And what I will do is build a classifier that will be able to tell me for a picture, does it look like Gromit or does it look like Wallace? OK, get started with AutoML. Did I click? Yes. Let's create a new dataset. It's a little bit small. Here it's better. New dataset. Let's call it WJ. OK. And it's important that I select the checkbox Enable Multi-Label Classification, just in case a picture would feature both Wallace and Gromit. OK. And then I will select some files, some input images. And what do they look like? The input, they look like this. Pictures of Wallace, pictures of Gromit. And I put all of the pictures of Wallace in a folder, all of the pictures of Gromit in a folder. Then I make a zip of these folders, and I will upload this zip. Let's do that now. Zip file, open, create dataset. And this product is still in beta, and it's not very fast at importing picture. Let's see. So my dataset is about 3 megabytes, featuring like 300 photos, but very low resolution photos. It's importing the images, and I skip that part and go directly to a dataset that has already imported the pictures. OK, I have some already labeled pictures, because remember, this is supervised machine learning, which means it already has hundreds of photos of pictures of Wallace and Gromit, and it knows the correct label. And I cannot evaluate and predict it yet, because I have not trained my model. OK, let's click on Train My Model. It says, yes, I have more than 100 pictures per label, which is very important. Start training. OK, this will last for less than 1 compute hour, which is free. OK, start training. And in my experience, this takes about 15 minutes to make a classifier, to make actually a neural network that will be able to infer and predict on new pictures that it has never seen yet. Now, back to the slides. I did import the zip, and inside the zip, the folder names were the labels. I did click Start Training. So what do we have for machine learning options, specifically to get insight about pictures and to get predictions and inference? We have vision APIs. For example, Google Cloud Platform Vision API. What is it about? It's a classifier that already exists, that already has been trained on millions of data, and you just provide a picture to it, and it will infer what it sees on the picture. For example, if I give it this photo, it correctly infers that it looks like parachuting and sky and cloud with some high confidence. The percentage that we can see here is the confidence. It's 98% sure that this is about parachuting. This is correct. But now, it's not always easy to use such generic information to make useful things in an information system. For example, if I have a lemon farm and I use Vision API with these two pictures, it will correctly infer that the first photo looks like lime or lemon with high confidence, and the second one, okay, it's definitely a lemon. But what if the point of my system is to tell the computer in an automated system if the fruit is ripe or not? We have the immature fruits and we have the ripe fruits. The one on the top looks like, I would like the system to tell me that it looks like no more than 30% ripe, not ripe enough, and the one below is does definitely look ripe enough. So this is not AutoML API, Vision API don't give me the specific information that is useful for my system. Inference provides me with predicted information. What do I do with that information? It's more useful when it's actionable. I give you a few examples of actionable prediction. If my user uploaded an appropriate picture, and if I am able to detect automatically that it's an inappropriate picture, then it's very actionable. I just delete it because I don't want other users to see it. I don't want children to see it. What if I'm in a factory and I take a picture of an item on a conveyor belt and I see that this component looks like it's for conveyor belt number 4. It's very actionable. I tell the robot to take it and put it on conveyor belt number 4. Now, in the lemon farm, if I see that the fruit is not ripe enough, this is actionable. I put it aside. I don't sell it on the market today. I wait for tomorrow. Okay, so I need a custom model. I will need with my own labels, for example, ripe or immature. I will need to make some more specific inference. So my options here are building a neural network from scratch that requires a lot of time and money, a big team of data scientists and software engineers that are very skilled. Or I can use TensorFlow from scratch to build a neural network. And I still need quite a few data scientists and software engineers, a little bit less, and TensorFlow, and a training set, obviously, because the model graph is not enough. I always need an input data set to be able to build a model, a classifier. Or I can use TensorFlow to make some transfer learning. Have you heard about transfer learning? A few people only. So what is it about? It's about taking as an input an existing model already trained on millions of data, and it consists on several layers of neural networks, which we call hidden layers. And then we will use this as a base model to retrain it with our custom data, for example, lemons, just to train the last hidden layers and to build a new transferred model. You can do this with TensorFlow, and with just a few data scientists and a good training set, you get a model. Now the question is, does it exist something in between that is as easy to use as Vision APIs, existing model, and as powerful as custom model built with some, for example, TensorFlow? And this is where AutoML comes into play. So AutoML, it takes care of a few steps for you, splitting the data into a training set and a test set. For example, 80% of the pictures for the training and 20% for the test. And thanks to the test set, the tool computes the recall and the precisions. I'll get back to this later. Then training the model, and then deploying the model, meaning making it available online, ready to make inferences. It's important to note that AutoML doesn't remove all of the machine learning related work. Gathering and a dataset that is large enough and relevant to your use case is still a huge part of building a classifier, and that part is not automated. You still need data scientists for this. Very important. The input dataset, usually with AutoML vision tools, you need over 100 pictures per label that you would like to be able to infer, and low resolution is fine. You don't need a high resolution picture to train a model. Low resolution is perfectly fine. And there is a UX challenge because AutoML tries to automate as much as it can for you. So you will need an ergonomic way to provide it the training set. The training set consists in pictures and labels. So the tools I'm presenting today, they all have APIs to show input data, the input images with the correct label for each image. And some of them also have a nice web user interface ready to make a model without any line of code at all. So I will present 4 tools that exist on the market today. Machinebox, it's a British tool. It's a the component is called classification box. This one, it exposes in API. So how do you use it? You register at Machinebox, then you pull a Docker image, then you create a model. This is a REST request to your container that is running locally. Then you add training images. So in this REST request, there is a payload in JSON of a base64 encoded image and the correct label Gromit. This is what I put in the file train pick one, and then it's just a REST API call with curl. Then in the request payload infer.json, it contains an image, another image encoded in base64. And the answer, the prediction is Gromit with confidence 80%. And this is correct. Well done, Machinebox. I don't have enough time, only 30 minutes today. This is why I'm not making a demo of all of these tools. Sorry about that. So, next tool, Microsoft Azure Custom Vision. How do you use it? You create a Microsoft account, then you create a project. There exists an option that will let you download a lightweight version of the model at the end to a mobile app, which is a really nice feature for offline prediction. Very nice. So what do? You create 2 labels, Wallace and Gromit. Then for each label, with the web UI, you upload images, and this is fast. I like when it's fast. Then you train the model, and this is also fast with Microsoft Custom Vision. Great. And then it tells you the estimated precision and recall. I'll get back to that later. Now a quick test. I want to test the model myself, and I will provide it with a picture that it has never seen before, either in the training phase or in the test phase. So this picture it has never seen. I upload it to the web UI, and it infers that it is Wallace with 99% confidence, which is correct. Well done, Microsoft Custom Vision. Now, if I upload this guy, which is also anonymized, and I want a prediction, it tells me with a high confidence that this is Wallace, 93% sure, which is not correct. So maybe I should tweak a little bit the training so that this person will not be inferred as Wallace. Okay, next tool, Clarify. It's another competitor. So how do you use it? You sign up at Clarify. Then it has an API, which consists in 6 client libraries for 6 programming languages. and also a REST API ready to be used with curl. So here I scripted a small curl command that imports a training picture, and the JSON response says, OK, I ingested this file. Then similarly, I create a new model. Remember, it's all a REST API. I call it with curl. It says, OK, I created the model. Then another request to train the model. It takes a few minutes. The JSON response says, OK, I trained the model, and here is the ID of this version of your model, because we need a version ID to specifically to call the inference part. And then when I make the curl command to make a prediction, and I show it to JQ for a pretty-printing JSON, what does it say? This input image is recognized as Wallace with confidence 97%, which is correct. So well done, clarify. Then if I give it a picture containing the 2 characters, it is inferred as containing Gromit with confidence 84%, correct. And it seems to be inferring Wallace with a low confidence of only 29%, which is incorrect if we have, for example, a threshold of 50%. So not great. And also, it's not that great that if I give this picture, it infers me Wallace with very high confidence, but the next picture, it's basically the same, but not cropped, with another character, and suddenly the confidence for Wallace dropped to 29%. So there's something going on here. It's not always easy to make some multi-label classification. And now I will continue the demo of Google Cloud Platform AutoML Vision. I hope it has finished training the model. I do hope. But I was speaking very fast today, so it's not even sure. It seems it has finished, so I can evaluate, meaning it will tell me the estimated precision and recall, and it tells me this for each label separately. It can give me the confidence for label Wallace, for label Gromit. It all depends on a threshold, a confidence threshold that I decide. By default, it is 50%, which means over 50% confidence, it will be regarded as predicted, and under 50% regarded as not predicted. And I can adjust them. Precision and recall, they always go together. In an ideal world, they would both be 100%, but in the real world, classifiers are not perfect, and depending on the threshold I decide, it would give me a better recall or a better precision. I'll get back to that later. Now I can try a prediction. I hope the model is warm. Let's try on 4 pictures. So this one is predicted as Wallace with a high confidence of 97%, which is correct. Well done, Google AutoML Vision. Next picture. This is predicted as Wallace, as Gromit with very high confidence, 99%, 99.7%. Well done. Then this one is predicted as Gromit and Wallace, and both with a confidence over 80%, which is pretty good. Okay. And then this guy is detected as none of the above. And this is a trick. Actually, I created a third label, which I called none of the above, and I uploaded a bunch of unrelated pictures, some of landscape, some of famous people, and some of other clay animation character, just to make sure it would be able to tell, it seems to me that this picture does not contain Wallace and does not contain Gromit. Okay, and then it explained me how I can use the APIs to do the same inference, etc. Back to the slides. So recall versus precision. The recall, it's between 0 and 100%, and it means if there were 100 Gromit pictures to detect, out of those 100 pictures, how many will I correctly detect as Gromit? So let's say a high recall of 97% means I did detect 97 of them as being Gromit. And precision, it's almost the opposite, is say that I detected 100 pictures as being Gromit. Out of those pictures, how many are really Gromit? So if I have a pretty poor precision of only 70%, it would mean that in my set of predicted Gromits, 30 of them are not Gromit in reality. So that's why it's related to the threshold. If I decide to have a high threshold, because I want a high confidence in my predictions, I will indeed have a high precision. But that would mean I would have a smaller recall. Maybe there would be some images when in doubt, I would not infer them. On the other hand, if what I want is to find some needles in a big haystack, maybe a low confidence threshold is enough for me, and so I could get a better recall, but at the expense of precision. Maybe some of my needles would be just hay. I would have to post-process it again to make sure they match my query. Okay. I have the choice between making some single label training, meaning I would cut the pictures and upload them only as being Wallace and others only as being Gromit, or I can decide to also upload and train on multi-label pictures. And it turns out that the second option is better in my case. I end up with the same recall, as I still have the same inference power, but I get a better precision if I uploaded this picture saying this is Wallace and Gromit. It is better than uploading two pictures and telling it this is Wallace and this is Gromit. Now the question of the negative sample. This slide is broken. Okay, it's not a big deal. It just means that it's a good idea to be uploading not only pictures of Wallace which are in interest to me and pictures of Gromit which interest me, but it's also a good idea to upload a bunch of unrelated picture, landscape, other character, etc. It has a very tangible effect. It is if I upload this guy, if I didn't train with negative examples, unrelated pictures, then even with a Google Cloud Platform AutoML Vision, he would be detected as Wallace with very, very high confidence, which is incorrect. But if I did train a negative example, it is correctly inferred as none of the above. And again, I say none of the above just means not Wallace and not Gromit in my use case. There is a REST API for doing inference. So I have a host, AutoML Google APIs. Then I get a security token, authentication token. Then I make a curl command, just like with the other tools, and I get the inference. This is ready to be integrated in any of your system. We also have some integration in Python, Java, and Node, and this is more convenient if you are using these languages than doing some REST RPC requests. And in summary, I would say that building a picture classifier is now easy because most of the automatable work is automated. In this demo, I didn't write any line of code. I could build a classifier with the mouse in just a few clicks, waiting a few minutes for importing the pictures, then waiting a few minutes to let the model train itself, and that's it. I get a classifier ready to infer and ready to integrate in my system. Takeaways are, first, a warning. You still need to gather a lot of data. The more of input data you have, the better your data set for the training is, and the better the results of your classifier will be in terms of precision and recall. And this is not automated. You have to do the job, the work. My advice is to design actionable labels. So think of what would make sense in your system, something you can make decisions upon. And then I would say that testing AutoML is very straightforward. I had fun testing these 4 tools. It just took 1 or 2 hours for each because it was straightforward. And with these results that you will get in a few hours, you will know if this would fit your need. Is the recall high enough? Is the precision high enough? What does the integration look like? It's really easy to try, and I encourage you to try some of these tools. It's very easy, and you don't have to be a skilled data scientist. I'm not an expert in machine learning, and you don't even have to be a developer to try these tools. I also recommend having a look at these 2 videos. So Sarah Robinson, she made quite a lot of video about AutoML vision. And Yufeng Guo has a really nice trick in order to create a dataset consisting of hundreds of pictures. He takes a video of the things he wants to predict. He takes a video with various angles and zoom and lighting, etc. Then he extracts all the frames of the video, and all those frames become pictures for the input dataset. So in just a few minutes, you can get like 2,000 input photos for your classifier and get some interesting results. That's it for today. Thank you very much for listening. And I think we have 3 minutes for questions. Thank you. Yes, one question.
Will you always get the same score for the same image?
Yes, once a model is built in the tools I've used, this is almost deterministic in the sense of it doesn't vary unless you retrain the model. But if you're just making inference, yes, you will get the same inference for the same input. Yeah. What do we have?
Others class. You had the Wallace, the Gromit, and none of the above, but you also had a 4th class, others. What was that?
I'm not sure. I would have to check others. Let me check. No, actually, it's not on the slides. It's on the demo. I would have to check that, because definitely I get better results if I do create myself a synthetic label, none of the above. That might be the purpose of the other label, which I did not create myself. I will have to check with my colleagues. Thank you for the feedback. Yes.
Did you try also Amazon, AWS?
No, I did not try any tool for Amazon, so we can discuss it afterwards if you want. I'm not really aware of them. I heard Watson. No, I did not try Watson. Only for the 4 tools I showed today. You have also to be aware that a lot of tools in the market are doing actually different things. Like, for example, TensorFlow is a powerful tool, but that you have to programmatically tune to make a model. And a lot of vendors are doing some vision API. When you don't train a custom model, you just get some generic inference. And I was focusing on the AutoML landscape, which is about supervised learning of here are some pictures and some labels. Please make a model and ready to infer. And at the time where I made this demo 2 months ago, I was only aware of 4 available tools. Maybe there are a few more. Well, that's it for today. Thank you very much.